Hello everyone, me Vakif. So we are gonna talk about the summation of the values from the initial to the last value. So let's start. Before getting started to the coding part, I would like to display the mathematical part. I mean the logical part of the coding to understand the algorithm. First of all, I would like to mention the example from these values, uh, which is from 3 to 7. For example, our R0 is equal to 3, our R1 is equal to 7, R2 is equal to the summation of the numbers. Secondly, which is equal to 3 to 7, it is equal to 25, but we will do it later. And our R3, it's a constant value, which is 4, because every single word consists of 4 bytes. So let's start. As you see, our R0, which is a summation, it's equal to 0. It's our initial value of the sum, and our R0 is equal to 3, as you see. And now I would like to emphasize that our R1 and R3 are constant. R1 is the constant as we decide the number. For example, we set our R1 number as a 7. It will be constant until we finish this program. But R0 and R2 will be changed. You will see. As you see, R2 is 0, R0 and 3, and then our summation is equal to R0 and R0 plus R2, which is equal to our R0 is 3 plus 0 is equal to 3. Alright, now our R2 was equal to 3, and our R0 is 4, because when we while we are getting the value to additional, while we add the values sequentially, the initial value will be moved forward. Right now, as you see, our R2 is 3, it is summation, and R0 is 4, and summation will be 3 as a summation plus 4. 4 is our initial value for the summation of the 3, which is equal to 7. And now, as you see, our initial value will move forward to the 5 because of the summation. Because our summation is 7. Our summation is 7 and 3 after 3 and 4, and that's why our initial value is 5, and our R2 will be 5 plus 7, which is equal to 12. Our new value, I mean the R2 is 12, and that's why our summation, which is R2, is equal to 12 and R0 will be 6 for the summation value. This is the sum of this zero value is 12, and that's why our initial value will be moved to 6, and the summation will be 12 plus 6 will be 18, and and the last part is the summation is at 18, and R0 will move to 7, and the summation is 18 plus 7 is equal to 25. It's our algorithm how assemble work. Let's move on to the coding part. Let's move on the coding part. Firstly, we are gonna apply the algorithm as I explained before. Let's apply it on assembly. Global move R0 which is equal to hashtag 3 our R1 is equal to for example 7. I am taking this example from the example I explained. I don't confuse anything to make this explanation more clear. R0 is equal to 3, R1 is equal to 7, R2 is equal to 3, it's our initial value as I said before, and R3 it's equal to byte, and as I said before it's a byte of the word. Move R4 let's do it later because there's a reason to do it later. Let's look checker move PC R5 let's keep it like that. Let's keep it like that, and our loop addition R2 is equal to R2 plus R0 as I said before. There you go. Yes, this one. R0 is equal to R0 plus R. I am applying this formula on the assembly and add R0 is equal to R0 plus 1. It makes the variable move to the next variable. As I said before, is the summation is at 7, then the initial value will be moved to the 5, for example, or the summation is 18. In that case, the initial value will be 7. It is something like that. Yes, it's something like that. It's a comparison. This function is for to compare if actually as if you give the attention, if I don't know if you give is attention or not, but the problem is actually R1 should be bigger than R0, otherwise we the program should be end up, and that's why we need to compare R0 and R1, and of course R1 should be bigger than R0, and idle function R5 PC R4. I am gonna explain later. PC R5 and let's move on. The idle function is for to take the program come back the address. It depends on the input value, and the move function is for to take this program come back to the loop if R0 is less than R1. Otherwise, the program reach to the end function and the program will be done. Let's run it. Compile where let me see what's wrong. Yes, this part. As I said before, it is for it is the R4 is equal to -20, and it is for to take the function come back to the loop until R0 extend R1. That's why I wrote idle and move loop functions. So let's compile it. Yes, compile succeed, as you see. And I would like to mention that you can ask that why I wrote -20, because as I said before, every word consists of 4 bytes, and the differences between the start how can I say, the differences between the commands is equal to 5. I mean, there is a 5 command differences, and every command consists of 4 bytes, and that's why I wrote -20. Let's try if it works or not. Let's step into R0 is 3, as you see. This is the left side. Let me check if it works or not. Yes, it works. R0 is equal to 3, and R1 is equal to 7, it's our last value, R0 is our initial value, and R3 is equal to 4, and our PC, I mean the program counter, is C, and let's move on. And R3 is equal to 4, it's a constant value, and it's our, let's do it like that. Yes, it's our R4. As you see, minus 20. Minus 20, as you know, it is getting back. That's why I wrote a minus 3. The decimal signed, it is a minus 20. The decimal unsigned, it is the blah blah blah. I don't like to count it. They are the complement numbers, and that's why there's a huge weird number. Anyway, let's move on. Sorry. R5 is 28. Because when we are, for example, when we see first row, the program can anticipate the 8 rows, and that's why we apply, how can I say, the function will be, the calculation will be like the 20 plus 8, and that's why R5 is equal to 28. Let's move on. Hexadecimal. Program PC is equal to 1C, and our 1C is equal to 1C, 28. It's the same number, right? The number I showed before. And our R2 is 3, and summation is 3. R0 move to 4, 3 to 4. Program counter is 28. It moved to 2C. It's 1C. The loop, right now we are in the loop. R2 is equal to 7. R0 move to 5, 4 to 5. As I said before, when the summation will be changed automatically, the initial value will be moved to the next value until the end. It's our program counter to see. Let's check what 2 is equal to. Is it 44? Decimal unsigned. Let's check it. R2 is equal to 12. It's a summation, and automatically R0 move to 6, the next value. The program counter is equal to 4, 44. It 20, it comes back for the function of the movable, and there's addition function. R0 is equal to 7, and program counter is 40, and the movable where on the movable function, and program counter is a 44, and it comes back. We can continue, right? R2 is equal to 25, R0 is equal to 8. R0 is equal to 8, and it is this value is bigger than the last value, which was 7. That's why it will stop here. The moval, after moval, you will see that it will move to end. Yes, you see, it moved to 8 because R0 passed over R1, and that's why. So that's all. As you see, the program stopped when R0 passed R1, and that's all. Thank you for your attention.